Well, we don't have a homework due today. Um, but there will be another homework due next Monday, which will be on the polyphonic FN things that we will look into today. We will look into polyphonic things. We've looked into FN things. So basically, you want to try to wrap them together. That's the idea. We will see it. There's some things that you have to do, but you will just explore these things. Otherwise, it's still the same, sort of the same idea. Grab in a bunch of different components, try to support some of the features that we've talked in class, and a lot of routing, of course. Cool. Um, so I guess we can get started with recap about what we've done last week. So last week we were basically looking into this FN synthesize thing. But the idea is that now we are modulating the frequency of a sound. Um, the sound. Oh, that's close. Okay. Sounds pretty bad. Anyway, that's frequency modulation basically. It's always tricky to work on computer music or digital synthesizer using headphone. It will be always pretty tricky. But anyway, now we are modulating the frequency. So that's sort of far from the FN scenes that we end up at the end, right? So we talk a lot about different things. We will have a carrier. That's basically your frequency, the base frequency. And now you want to sort of like change the things a little bit. So this will be 440 hertz. Then you want to make it, just like swing between or move between, fluctuate between, say, 435, 420 hertz to say 460 hertz. So this will be plus minus 20 hertz ish things. So that's sort of the idea of FN synth, where you will have a carrier frequency that will be your base frequency. And now you will have a modulator that's sort of like moving around some frequency range. And that frequency range will be the modulation depth. But this things only works for a specific, frequency. So now if you want to make it a synthesizer, then you want it to support whatever frequency that you know. So in this case, you will have a frequency, say whatever one you click, then you get a specific number of that. Then you basically just try to have this number as some percentage or fraction of your input number. So in this case, this is called harmonicity, where basically you could imagine this same times 0.1, then they become 44 hertz. Then you just, move around for 44 hertz. So you move 10% fluctuation on the base frequency that you have. So now this things no longer depends on your input. This becomes like 0.1, your fundamental frequency. And the modulation depth, you could also do something like that, make it depends on something else. And in this case, now the modulation depth, we will also make it, we know that it depends on the frequency of 0, but you can also make it something that will go from 0 to 1 and go back to 0. So in this case, hopefully it's not too loud. But you can change it. That's all right, actually. So in this case, it's like your modulation without modulation go to maximum modulation, back to no modulation. That's what you see here when I press a key. The modulation from no modulation, and back to no modulation. So in the end, this is what we get. So it's a little bit trickier. So you get this part is to see what the frequency would be, and this part is to see what the modulation depth would be, how much fluctuation on that frequency that you want to do. And then that frequency modulation will be modulated with this, that go from maximum modulation to no modulation. And at the end, once you have all the modulation outputs, finally, you still apply sort of something like ADSR envelope, even though it's not technically ADSR. But anyway, you apply some envelope on top of that to create the final sounds. So this could be something that you can get. So you can imagine that this is the modulation path. You can start with something very small. But you can also change the thing. So this one is the attack, and sort of like similar to sustain and release, even though, but that's basically the envelope that you can modulate the final outputs. Questions on FN things? So if you have like the good old Yamaha, I forgot the name, PX7 something. That's the iconic FN synthesizer. Yamaha developed the FN synthesizer, I guess like 4 or 5 decades ago. And a lot of sounds is just like playing with these, modulation depths and, the harmonicity and the envelope so that you create different kinds of sounds. And that's essentially what you would do in homework 6. So in homework 6, you will just try to play with different cases. In this case, we are not yet polyphonic yet, but we will see how we can make it into polyphonic synthesizer. So previously, when you are working with MIDI notes, where you don't need to care about polyphonic, because your MIDI synthesizer actually already handled that for you. But now if you want to do it, to do everything in Max, then you will have to figure out how to do that. And that's essentially what we are going to do today. Cool. Polyphony. So before we jump into polyphony, this is one thing we want to try, and somehow my keyboard is not working. I don't know why. Okay. So this is the thing that's essentially our simplest synthesizer, what it could be. So basically it's sinusoid function. So just like, let me just play something, I guess. Let me just grab one of the notes. Oh, this is polyphonic. So when I click it until it cool. Let me play something higher, I guess. So you can see in the middle part that you can see the ADSR thing. So you have an attack and then you drop back to the sustain. So sustain level is 0.5. So once again, let me grab the slides. Where's the ADSR slides? Yeah, this thing. So the attack is the time. So attack is the time. Go from 0 to 1. Decay will be the time. You go from 1 to the sustain level. So the only one that's not time is the sustain. So sustain is what this number corresponds to. In this case, we are doing 0.5. So it will drop to 0.5 all the way until you have the node off event. So, think about key up thing, and then it will release. So the time this time would be release. So ADSR, ADR would be the time, but S would be the level. So in this case, we can actually just grab this ADSR tilde things to do it for you. So in this case, attack will be 10, D will be 100, S will be 0.5, 500 will be R. So you can see it here when you play it. You see that the attack will be very short. If we increase that into 100, then you will see a different behavior. So now you see the slope is much smooth. Let's do it even further. Let's do 1,000. So it will take 1 second to go from 0 to 1. So you see a very like a slope that goes up for a second, and then it will drop for a 100 millisecond back to 0.5 until you hit the node off, and it will going back. So this ADSR thing, you can actually grab it with N and ADSR tilde, then you can get it. And you will see at the top here, there will be 5 inlet. And it will just show you what those are. So the first one is like trigger this envelope. So in this case, I'm connecting the outputs of the keyboard. So this velocity would be, some number. So we can actually show it here. This will be some number, whatever that number is. So when I click it, it will be 117. That will be the velocity. But when I release it, it will be sending a 0 because that's node off. So node off event will always be 0. So these things divided by 127, then you can see that it basically turned it into sort of like, let me see. Let's grab a message here to see what the thing shows up. So when I click it, it will be some number. And when I lift it, then it will be 0. So now this trigger, basically everything that's non-zero, it will trigger it. And anything that's 0 will sort of like initiate the release thing. So this is what ADSR is for. But for the other inlets, that's basically A, D, S, R. That's very intuitive. So, you can do something like this. Then you can control the ADSR. These are the default number, but you can, of course, change the ADSR. Cool. But that's what you can do. And the left is just basically grabbing the MIDI node number, 60, whatever that MIDI node number, turn it into frequency. M to F would be MIDI node number to frequency. There's also F to M. We'll do the other way around. And you use this cycle tilde thing to generate the signal, sinusoid signal. And now you apply this ADSR on top of this sinusoid function that you have. And that's why you see in the end what it looks like. So one thing we could do is that now, rather than showing this ADSR, we can actually show what this thing is. So now I'm showing the final output, the spectrogram of that. And now if I click one of the nodes, then you will see that it's just the same frequency, but it would just go to magnitude 1 and back to 0.5 until I close this node. Then it will slowly decay until 0. So once again, nothing, and it will grow to maximum magnitude, and go back to 0.5. That's the sustain level. And then once you lift it, it will be gone. So that's essentially a very simple synthesizer, I guess, that you can do. So now the tricky part is that how can we make it into polyphony? And so that's what all the trouble is. That we will see. Cool. So I will just show you how the things work. And then we will figure out how they work. That's the artifact. So I think last week we talked a little bit about it. So first thing is that we will have this poly thing that will basically, well, we have 10 voice and we start from voice 1. So we will have 10 voice. So the idea of polyphonic is that you want to have this file, but you want to create 10 copy of this file, and every one of that just handle one single note, because there's just no single way you can synthesize two notes at the same time using this, because everything will be doing one cycle, but modulate by one ADSR. So if you want to create multiple song, then potentially you want multiple of these. So that's essentially how these things work. Let's forget about in the middle, these two things. So the two things you need is poly and polytilde. So this polytilde is that, well, once you know the voice information, where which polyphonic voice you are creating, then essentially what this is doing is that this actually link to another file that I already wrote. If you click on the inspector, then you will see that here there's a patcher field where you can choose what patcher you want to use. So number of noise, 10 here, we already set it up. And you can also just write this down and it will show it here. But anyway, these things will link to a patcher. And so this patcher will be in your file. This my sound things that I already wrote. So we can click it and see what it looked like. So this is essentially what it looked like. In this case, I can also double click it to see it. But this is what that file looked like. So now you might see a little bit different from that. So think about these as like a function in Max Patch. So in Max, you can actually write multiple different patch. So what's going on here is that you take some input 1 and I, these are just handling different kinds of things. For this is for the polyphonic, but this also allow you to use this file as an embedded object inside another Max Patch. But basically you can think about these things just turn into, where's, you can imagine for this whole thing, there's just this outlet, and that's the inlet. So this whole thing actually turned into an object. Sort of imagine there's an object and you define like one inlet. And then you have an outlet. And this thing is called my sound. So you're essentially writing sort of like a function or sort of like creating a custom object. So you have inlet something coming in and you would do something and then you would send something out. So that's essentially what this object, this patch file is doing. So you will get something in, and that something in is the MIDI note number, what you're getting for that, but also the velocity of what you get. So there are like two things coming out. One is the MIDI note number, the other would be the velocity. So the MIDI note number, this is essentially what we just saw. MIDI note number, turn it into frequency, get the sinusoid function, and the velocity will divide it by 127 to determine whether it's on and or an off. And we'll send to this ADSR thing to together get that outputs. So once you have this is essentially what we just saw, right? You will have a sinusoid function modulate by an envelope. That's it. So once you create this file, let's forget about this poly thing for now. Then essentially you can do polyphonic things now. So what happened in this file is that this polytilde my sound thing is essentially creating 10 of this object. So you will have my sound 1, my sound 2, my sound 3, blah, blah, blah. You will have a bunch of different files, 10 of those. 10 of those. And what's going on is that this poly thing will determine the voice. and this poly tilde thing will, based on that voice, then, say now I play, C, E, G, then it will send a C to this, send an E to this, send a G to this. And when I close C, then it will send an information to C that now turn it off, send in a message to E, turn it off, send in an image to G to turn it off. So it's sort of like supervising 10 of these workers that's synthesizing the sounds that you have. So that's the high level idea. So what you're seeing here, it's a little bit tricky. So that's essentially just doing some swapping so that it works to that. So you can see here, that's explaining what's going on. Swap the message order so that the voice is sent before the pitch. So what's going on here is that this will output the voice number. This will output the pitch and the velocity. So now what you want to do is that you want the pitch to be sent, after the voice information is sent. So in this case, it's a little bit tricky, but let's just do it this way. The idea is that for outlet of Emacs, everything will be sent from the right to the left. So it will first send this information, velocity, and then pitch, and then voice. But in this case, when you do swap, then these two things will be swapped here. So now, this one will be voice, this will be pitch, this one will be voice, this one will be pitch. But now this two things will be swapped. Now this will be pitch, this will be voice. So now voice will be sent first. So this is important because voice, once it's sent to target voice, it will switch the voice and then you do the pitch thing. So the whole idea is just that you want to set the voice first and then trigger the sound. So that's what all these complexity is about. So I guess that's the explanation part. Now let's just try to make it work. It might take some time, but let's just figure it out. So the idea is that, well, you will need both of these. You want to create a file that has this my sound patch, but at the same time, you want to embed it into the bigger patch. Where is it? Where it is? Gone. Where are you? Oh, this is it. Cool. Let's try it now. Any question on why so complicated? Cool. Let's try it. So what you want to do is first create this thing and save it as my sound tilde. And in homework, basically you want to swap this as the FN synthesizer. Oh, I haven't talked about this, but we will talk about this later. Yeah. The noding thing is not working here. I still couldn't figure it out why. But anyway, hopefully the station is working. And you can actually start your free trial already. This we are close to, yeah, project, even though it will be due, the final report will be due on 15th December. But you can start your trial at least at the time of presentation, you will be done. Cool. Okay. Yeah, first this, and then do this. This will be connected to that one. To find this I thing, you know, even though it's optional, you can find it. Where can you find it? Plus. Oh, yes, here. If you want to play with these things, you can actually also connect these to play with it, to see what you are actually doing, before making it into polyphonic. Cool. Oh, one thing that you see here is that we pack these two things together. So I should. So oops, that's not a good idea. So we can pack and unpack. So here we pack the pitch. So pitch going out here, but it was swapped. So go to the left one. So this will be pitch, this will be velocity. So pitch velocity will be packed together into one message because that's what this is accepted. So only one pitch and velocity. Now we do unpack. 0, 0 will be like these two things are both integer. So it will be pitch and velocity. So you can pack and unpack stuff.
I can't get there's no outlet for my poly tilde. Same mine.
No outlet?
Yeah,
Oh, you have to do this, and then you will have this patcher field. You have to choose the file. So once you here, then you can click on the file that you have.
Oh, I see. So
Yeah.
we need a like a one shot? Or like what kind of
It just comes
is it in the max 9 folder?
no, you have to create the thing that right and save it. This thing. This is actually the my sound file. This one is this. So you can think about it as like a class, like an object, like a function,
Okay.
standalone function. So you are connecting that thing. So the idea is these things will open 10 of that file. Each of it will be one of the synthesizer, and you want to create 10 of those.
10 voices.
Yeah, essentially. It depends on this. So how many voice you want to create. So this is like one monophonic synthesizer. This will set it up as, I want 10 of those. And these two things will just handle how you do the job allocation. Think about parallel computing kind of.
Okay.
Yeah.
So we have to make that in a separate.
Yeah. Tricky. Good.
What's the I like how do we get that I?
You mean just click it and edit right? Oh, you mean
No,
which one?
The one with the
This
I.
thing? Here, the plus sign. The plus sign?
You go to the plus sign and you give you one that's
Like this one, inlet and outlet. I believe you can also do it with just inlet. Or you just do inlet. you will get it. You can also type inlet. Inlet, outlet. You want this thing to be the FN synthesizer rather than rather than this boring thing. Yep. Cool.
Build an FM into that file.
Yeah. There's additional thing that you have to work on, but follow the instruction. There's you want to save a preset. That's what you will explore.
Got it. Okay.
Yeah. But the preset is sort of similar to the one that we saw here. Somehow when I click on something, so that's the preset thing. So you can actually, so one thing about Max is that, whenever you open it up, everything is sort of like, reset. So you don't have the carrier frequency, it will default back to 0, right? So we can use like load mass or load bang, whatever that. But preset is another object that you can use. So you just use preset, then it will be a bunch of numbers you can click on, 1, 2, 3, 4, 5. So you can create a bunch of preset. But in this case, when I lock it and then click on one of those, it will actually load up. Yeah, okay. So you can save it. And I always forgot how to save it. I think shift, so you can turn something 3.5. Let's just try something, I guess. 440, it was save, yeah, even this 127. I think when you press shift and click it, it will save. Yeah, so you see that. So when you have 2 and then you click on this, then 443.5, then potentially you want 2.8. You can even change the volume. You can change this, and then you press shift to say you want to save on 6, save on 6. Then once you click something else and back to 6, that will refer it back to the 1. And it will save all the, programmable numbers that you see. So everything like duration, even toggle, numbers, the gain, everything that's clickable, kind of settable, it will save here. So that's essentially what you want to do in homework 6. Once you build the polyphonic things, then keep exploring these things and try to find some sounds that you find interesting, and then save some of those into preset. Then essentially what you create is just an FM synthesizer, right? Now you have an FM synthesizer that take note in or, keyed up, key in, and you will have a bunch of program that you preset. And that's essentially a MIDI synthesizer, kind of. Yeah. Cool. Back to this. Are we? Yeah. Save the. You want to save the file for now?
Travis type beat is something that
they want to create a new particle my side.
boy, they're making FL Studio on this.
Jack Boys 3.
Jack Boys 3.
At the right, that's a standalone one. Call my sound tilde. The tilde is something that's pretty tricky. Yeah, and the way how you link it is once you have my sound tilde.
Hao-Wen besides the
That's essentially what's going on. Cool. So maybe let me explain a little bit what's going on here. So what's going on here, all these weird stuff, is that essentially what we want to do is that we want to first set the voice that we want. So think about, you are building a polyphonic synthesizer, is that, well, we don't want to tell the things about which pitch to start before I know which one I'm talking to. Because we are, launching, 10 different monophonic synthesizer, right? So we want to know which one to start, which one I'm talking to. So this poly tilde thing is like launching 10 of those, and it doesn't know which one to talk to. So target $1, this $1 will be replaced by the voice. So it will be, say target 3. Then now I know I'm talking to this guy. And then you start like, well, I want a MIDI no number 60 with velocity 127. Then you send to this thing. So essentially what you want to do is that you first set the target voice, and then you send the velocity, the pitch and velocity. So everything here is just doing that thing. So what happened with this Poly 10.1 is that if you look at this outlet, there are 3 things. So you have velocity at the right, pitch at the right, middle, and voice at the left. So what Max is doing is that Max is like right hand first, left hand last. So it will actually send the velocity first. So it will trigger the things and the pitch and then the voice. So it will first trigger the pitch and the voice, and then it will send to this poly things. But that will create some issue is that you haven't switched to the voice that you're in that you want to trigger. So it might be, the next time now I want to do, voice 4. So now you have a target 4, and then at the same time you will have another pair of say MIDI 62 plus velocity 100. Now you have like these 2 message. What you want to do is that first set the target and then send this message to this target. But if you don't do this swap thing, because Max will do the right-hand side first, so it will trigger this velocity pitch things and send it to that. So what happened if you don't have this swap thing is that it will first send this message to the previous activated voice, which is voice 3, and then it changed to voice 4. So that creates some issue because the thing is the previous one, and then now you are using that previous voice. So this swap thing is to set the voice first before doing the voice changing thing, the pitch and velocity. So the swap basically turned out it doesn't just swap the inlet. It's like, why do you want to swap the inlet? The goal is to swap the order of education. Cool. So that's what is happening. And the other thing that's a little bit tricky is this poly thing. I don't know essentially if we can show it here. Let me show you here, I guess. So what I can do is that now we don't want to show this. Let's show what this third one is doing. No, it's not it's just a message. So let's take a look at this, like one of the monophonic thing. And this is essentially what we connect to the list poly thing, right? So what's going on here is that when you click on the note, it will say mute 0. So you hear some sound. Once you turn it off, it will still be mute 0, but at some point it will turn into mute 1. So what happened here is that you set up a note. We have like some magnitude here, and once you close it, after 500 milliseconds, once it turned into 0, then you send a mute 1 message. So this thing is automatically sort of like handling whether this voice can be close to save some computational power on your laptop. So think about, without this list poly thing, what this whole patch is doing is that creating 10 of these things. And some of these things will be just doing 0 velocity thing because there's no sound at all. But it's still constantly sending something, and it's just wasting your computational resource because it's just doing 0 processing. So it doesn't make much sense. So this poly thing that's connected to this mute 0 and mute 1 is basically letting us know which voice is active. So mute one, meaning that we can mute the thing. So if it's mute one, then the model, the bigger patch, the parent patch, would know that, well, we don't necessarily need to allocate any resource. We can turn that patch off. But now if like when you click on something, it will immediately send a mute 0. Then it knows that, well, this thing is creating something all the way until you send another message, the voice, target 1, 2, 3, 4, 5, 6, 7, target 7, and then some velocity 0 to turn it off. Then at some point it will become mute 1, meaning that now it becomes something that's just no amplitude. Then the model knows that now we don't need to allocate any resource to that. So this poly thing is actually sort of, optional. It's just saving your laptop's resource. I mean, the poly thing. This shows up somehow. Yeah. So this poly thing is just to handle this poly tilde thing. The things whether it should be on or off to save some resource. Cool. That's essentially it. Questions? Worry about homework? Yeah, it shouldn't be too tricky once you go over this and there's a bunch of random stuff like but all the troubles here is because you are connecting two things. So this is like a standalone file. For this parent patch, what it's doing is that, well, we are launching 10 instances of this thing. And that's why it's sort of like soft and dynamic. It's rather like a pre-built computational graph. That's the reason why it is a little bit complicated, but at the same time, that's why it's interesting.
When you say 10 instances of that patch, is it like that means 10 notes could be played at once? Or like why 10? Like where does that come from?
Oh, you mean why the number 10?
Yeah, like what is the 10 of this doing versus like 5 of them versus like 1?
Oh, if it's 5, then whenever you play a project until the 6th, then it will replace the first one.
Okay, so 10 notes can be played.
Yeah. That's the, some of these synthesized 10 polyphony column 10, then you might be wondering what that means. That basically means that, there's can only 10 active notes. So it's not only, your fingers. So sometimes with 16 or 32, because when you do like a huge project, at some point, the first note you play is still on. And then whenever you play the next one, that one will be gone. So you do want a large number of polyphony. And laptop is much powerful than some of the keyboard, like internal processors. So you can actually use 128 or whatever. Usually 128 is what people aim for. The maximum number, because it's very unlikely you have more than 128 keyboard keys. Good. Cool. I think we are done for today's stuff. A hint. If you want, save it and send it to yourself, or I don't know. You should be able to log into school's account anyway.
But your files aren't like I noticed that my stuff that I had saved last class was still here, but that's not always, is that always?
Yeah. I mean, if you save it in your the documents, I mean those sure. Yeah. Yeah, you can log in from your computer, so it's a bit tricky.
No, but like if I keep stuff in the documents here and it's under my like
Yeah. Next time it will be there. I think it's mounted on OneDrive. So technically you can log into OneDrive on your personal laptop, you'll see the same file.
Okay.
Yeah. I think it's on OneDrive somehow. It's like everything is on Google, but somehow this one is on OneDrive.
Okay, well,
cool. Yeah. Guess that's it. Have fun. It's the homework. Shouldn't be too tricky. The preset thing is that press shift and click on something, then you can save that preset. After that, you have to save the file, of course, but play with it. It's either Control Shift Alt, whatever, play with it. Next, we will also look into something interesting. Now we are back from this chaos. I promise. The rest of class is actually much simpler than what we've gone through in the past few lectures. Filters, mixing like stereo, drum machines, sequencers, some equalizer, but lots of those are built in, so you don't necessarily need to dive deep into why are we doing this at all. But anyway, and these now you sort of know a bit more on what Max is doing and what's the philosophy of Max, which is likely the biggest trouble when people started with Max. But next we will look into some of these. You can see, this is essentially how you can potentially build an equalizer, you low pass, high pass, band pass, all the filter that and you can actually create sort of like a drum. This is like equalizer that you can combine all these things together into an equalizer. So, imagine you are doing like some DAW, then you have the equalizer. By the Max, you can also create your own equalizer part of your whole Max patch that you can play with. And you can also design like Max plugin for that. And later you will see you can also use this to do subtractive synths. So basically you grab a noise and then you do the filter. So then you grab a sound and use that sound as the drum machines. That's what we will look into. That's called, subtractive synths, and additive synths is that what we explore, F0, 2F0, 3F0, what would be the percentage of those? So there are a different paradigm of synthesizers. And of course, FM synths, which is more familiar. Cool. Cheers. And think about the project as well. I think I don't think we should do the project pitch, but I guess one thing that would be helpful is that book a time if you want to chat about your project, but time to think about it. There's still 1 month left. Yeah, next Monday I will talk about hopefully, or maybe I will swap a little bit to talk about networking as early as possible so that you get a sense how processing and Max could be combined. Then potentially will expand how you think about your final project. For now, you might think about final projects as like, I hate Max, I guess. But, there's still something that's much more, it's easier, more manageable. And you don't necessarily need to do all these chaos. Cool. See ya.